Okay, we are going to show you the C7 caterpillar. Today we are going to learn the caterpillar C7 to C23. All of them are the same hardware, but the software is different. This one has two versions. This one is for excavators, and we also get another one. This one. This one is for machine and industry. The different is the MOSFET. The MOSFET is different. We say here, this one MOSFET is small, and the normal one, the MOSFET is big, much big. So they are the same one. Okay. Today we will going to learn the power of C7. As for C7, we have two boards. The top is the motherboard and a power board. Maybe we call the daughter board, motherboard and daughter board. This is the daughter board. The daughter board is the power board. This is for power. It's very simple for us. We get 31 pins here. This plug connect to the motherboard. So we are going to introduce the power of this C7. Okay. First, this is the plug 70 pins, and this is 120 pins. The power input here, we should to find a schematic files of this. Okay, we just found a caterpillar 336. We check here 336 and get the schematic files. The electronic, this is the hydraulic. We don't care about hydraulic. Today we are going to learn the electronic. Maybe I should find a part number of this. Wait a moment. I will find a part number of 336. Okay, this one. It's about 15 years ago, this one. We get the part number here, input here. And then we find the schematic files and apply. So this is the electronic. We just download the files. So we will introduce this file pin to pin. Every pin. I will show you. I will save this. Okay, let's turn on this, and we will check the ECM, the schematic files of 336. Here, the pink module is the engine. Okay, the plugs, this one. And today we will just introduce the power. First, the 7, we will from the top to the bottom. Okay, this is return. Return also connect to ground, the pin 5 ground, and the battery. We will check the battery. Fuel relay. Don't worry. Let me check. Okay, it's very simple. Okay, we will room out, room in. Okay, the battery, negative battery, 31, 33, and 35 battery negative. We will check the PCB of the C7 and also open the power board. Okay, this one, and also we open the power board of PCB power board. We copy this and yes, this one, the top and the bottom. So this one we just collect here, and this is the side we can see, and the other side of this one is like this. Okay, make it small. So this one just behind this, hide this. It's in the case. We can see the plug pins 31. Why is 31? Because this here we lost one pins. So this plug is used for you to identify which one is the pin first. This is the first, and this is 31. And now we will show you the power input here. User defined shutdown and engine start, and also battery. We need to check the battery here. 48, 52, and 53, the positive. Okay, let me show you here. We can see the input 43, the 43, the 53 and 55, 53 and 57. We will check the 57 here. We get the input because they collect together. 52, 53, 52, 53, 53, and this is 52. Yes, and also if we can click here we will highlight this these pins collect together, so they are the input voltage, and we just collect here 57, okay, 57. Also there's 40, 48, 48, 20, 48, 52, 53, and also 48, right? We check 40, 57, 57. Okay, I will just mark it, all of them, input. The 100 pin, no input, 教练哥哥。48, 52. This pin are input, they collect to the battery, and the negative. Negative it's a lot of them collect to the ground. Not only in this plug, but also this plug. We get a lot of ground here. So we just find someone on the first row ground, and the engine start the 70. We also call ACC, and we can find it here. It's the engine key switch. We just use the original one, engine key switch. So we can just collect only here. We get the power on. This is ground, and this is engine key switch, and this is the input. We just use 3 wires here. We collect 3 wires here. This is black, and this we just usually use yellow for ACC, and we will check here. The ACC is yellow, also yellow, yes. So we just collect 3 wires here. If we test at home, we just use 3 wires. Engine key switch, and below 30, 57. Input 57. Okay, here we just use 3 wires. Usually we use black, yellow, and black, yellow, and this one red. Okay, we just use 3 wires, and the input, we will find the input, we will highlight, and the input is also connected to the MOSFET. It's the drain of the MOSFET. This directly connect to here, and we can see the schematic files. This is the input, and then collect direct to the of these 3 MOSFETs. Three MOSFETs, and after the diode, this one gets a voltage. Here we get a voltage to open the P MOSFET. These 3 P MOSFETs. So after this, we can get the voltage input here. But this is just for input here. First input the battery input, and then second the MOSFET. This is very important, and we use this plug to supply power supply for the power board, and we just use the software to translate the word. It's easy. I don't want to type the here. We get the here. 24 input power supply is connected to the following power board through the J4 interface. The J4, this is J4 power supply. Okay, here we get the power supply. And why this PMOS can open? Because this diode gets the voltage down, and about 12 voltage. Here is 24, and here is about 20, about 12. So the PMOS can open this one. Okay, we just change this to here. D44, it's very important. D44. Here is the voltage regular. This one is a voltage regulator diode. So this is the very important one. And this is the TVS. It's also very important. TVS. It's the back side. It's the bottom side of this board, and near the P MOSFET, and we can see the pictures here. We get the TVS here. So usually, if we find the fuse breakdown, we will check the TVS. This is often broken. So here we get the battery input here, and these 2 resistance, and we can get the battery. The voltage of battery, ADC, log to digit, ADC for battery, for ADC to get the battery of the voltage, to get the voltage of the battery. Here we get the voltage. Okay, after input, and here we get a reference voltage here. Reference. This reference is also very important. Why we should say it's important? I will show you. Here we get a reference voltage here, and I will show you why this is the reference. Here we get a reference, and we will check. We just copy and find it. 1, 2, 3, 4. We use the 4 points of this voltage, and also this 62 and 64. Why we get the 62 and 62 and 64? We will check it. 62 and 64 here, 62 and 64. But we don't use. Here we don't use, so we don't care about it. We get the voltage, and here, if the voltage is above this, and here we can get the high voltage, high. If here we input the high voltage, here we will get a high, because this is the reference. Here get the reference here. We will just click here, collect them together. Use a while to collect them together here, and also these pins. But 30, 32 and 34 we don't use, so we don't care about it. Here we get the voltage, the reference. So this voltage is used for three parts. 1, 2, 3. These 2 parts we don't need. Here is high. Here we get a high level, and we also get a high level here. So also is this one. So does this one. Okay, and here is the ACC, power on. So we call the power on, ACC. This is very important. We get a ACC here, and after this resistance, we get a voltage here, and here we can get the voltage here. It's above this reference voltage, and this here we will get a high level. This is very important, high level, and this is pin turf of this one, the power board. Also here we get the turf is open the power board. 12 here, 1, 2, 3, and 16 the 12 is open. We will make a mark on it. Use the ACC to turn on the power board, and we should also find the input. We can get the input here. So it's very easy for us to repair this one if we know about it. After this MOSFET, we get the input voltage, and this MOSFET on, this power on, and we get 3 holes here, and this one connect to the power board. These 3 pins, 15, 16, and 31. These 3 pins is the input voltage of the power board. Input, we get the input voltage from the 3 MOSFET, from the 3. Thank you for your gift. The 3 pin MOSFET, 3 pin MOSFETs. P-channel is the P-channel MOSFETs. 3 P-channel MOSFETs of the source pins, S pin. So we is short for it. S pin is short for the source. But we know the PMOS, we need to input the voltage from the source to drain, right? But why? This one connected to the drain and then go to the source pins. Why? Because here we get a diode here. We get a diode, 1, 2, 3 diode. This diode can get the right direction of the battery. If we collect the battery, we get a wrong direction, and this one can protect the board, the ECM. So it's very important. This is a very important part of this board. So this is not mixed wrong. The designer of the carabiner, they are very smart, right? They don't mix wrong. They are smart. They use the diode to protect the ECM. It just needs the right direction of the battery pass through the P MOSFET. So it's very important here. We get because the P MOSFET we use for switch, we should get the power in the source pin. But here we get just through the drain pin. So it's very important, right? Okay. This is the TVS for the overshort. TVS. This is the TVS for the overshort. We get the overshort voltage here, and this one can just put the voltage to the battery. So it's charged by the battery and protect the ECM. Okay, here we go. And also we get a high voltage here, and this is the diode. We get the diode here, and here we check it. If the power is no, it's no here. And if the power on, we get the power on. And we also this one. What's this one? This one is for this one is short for is for delay, is for power delay. Why we turn off the ACC, and it's also can open the power. This is for the we get a diode here. We just collect the high voltage here, and this is short for this is for delay. Caterpillar, U25 is Caterpillar chip. It's a chip of Caterpillar, and the pin of the W14. And after ACC is gone, ACC is gone, is off. Okay, gone is not good. Is not a good word, right? After ACC is off, and this can delay for delay, DELY, delay for turn off or turn off, because some of we know because thank you my friend, because after this we get why this is very important, because after reconfiguration here we get the configuration after reconfiguration we should turn off the ACC and not power off, configuration and ACC off and ACC off. We just turn off the ACC, but we find that the current do not off very quickly. Why? Because here we get the delay. This is delay for turn off. It's very important. Why is delay? We get the Caterpillar. The U25, which one is the U25? We can get a picture here. Which one is the U25? Here is the U25. This one has a mark on it. It's marked with Caterpillar, and the pin of W14 is the delay, and J4 is for the plug. This one plug, J4 collected to the power board. Yes, this is very important. J4. Okay, so we will review this. First, power input from these three P MOSFETs and from the source to the drain. And it's not made a mistake here. It's very important here. We just explain to you why it's very important here, right? And after we get the power, but we don't power on. Why we don't power on? Because we need the ACC to turn on the power board. Why this ACC can turn on the power board? Here we get a switch here. This is the switch, and we should give it a name. Voltage comparator, right?
Voltage comparator.
Yes, this is the voltage comparator. We don't make a mistake. And here we get the voltage comparator. Here is the voltage comparator for ACC. Here, this is the normal function of this point, right? Voltage comparator here, and if the voltage of ACC is high, is above, then this one, the positive is high than the negative one, so the output is positive, right? And this resistance R231, this resistance is very important. Why is it very important? It's for the transistor, and for the limit the current of the transistor, this one, and we will get a high level voltage here, and to turn on the power board. Here is the power board. So we just translate all of these notes to English, so if you can enjoy it. Okay, here, and this is power on, and now we can get to the parts connect to the main board, to the power board, J4. We made a mark here, J4. So J4 is the plug. It has 31 pins here, and connect to the power board. This is C7. We see the power of C7. Okay, today we can just find the how to power on. And now we just go to the power board. Here is this one, 1, 2, 3, 4, and 16, and the 31. And these 4 pins, which is just to fix the board. So they don't have the connect to the electronic. They don't have electronic functions. They just to fix the power board. And this one is from the L6 layers, and from this direction, this side, we get this side. And after we remove the motherboard of this ECM, we can find the power board here, and this is the first side. We get a first side of this board, right? So this one, that's all. This one, they don't have a lot of sensitivity on it. Why? Because this is short. This is another version. We get 2 versions of this board, the power board, but this one is also very useful. And this is for the Caterpillar's truck, and it's okay because all of these components, they just to delay for the power, and some of them is useless, so we don't care about it. And this is the other side of the power board. Okay, I will show you. So we get the power input and ground, and also the ACC, right? ACC, which one is ACC? 12, 1, 2, 3, and this is 12. We get 12. 12 is for open this board. Now we see this power board, okay? And we should translate this to English, okay? First we translate this to English. The pin 1 and pin 2. This is the high voltage for the injectors. So if we translate it to the English, and it becomes a very long sentence. Pin 1 and pin 2, not fit, because this translation is not very good. We just pin 1 and 2 pins are the high voltage outputs after being boosted. This one we just use 24 to boost. This we get a boost circulate on the power board after being boosted, running from 17 to 110 voltage. Why? Because the C7 and the C9, the injectors used the 70 voltage, and the C13, C15, and C18, also C23, they used the 110 voltage. The injectors are not the same one. The injectors need a very high voltage. So this one, and I will show you why this can be changed from 70 to 110. It's very simple. It's just changed the feedback resistance. So this is the very classic and very useful circuit for us. The feedback, and this is different from other modules. Not other modules. This is different C7, C9, C15, and C18, right? Okay, and the pin 3 and pin 3 and pin from the, and this pin is output. First they input the voltage here, and after the power board is okay, and it will return a voltage to the motherboard, because the motherboard, a lot of them need to use the voltage, such as the MOSFET, the relay, and something to open the relay. Okay, this is input, and then from the power board to output. So it's difficult, right? But if I teach you, it's simple. I will show you, because a lot of them, they don't know the English, they don't know the Chinese, but they know, most of them, they know the English. So I translate to the English, not fit, but pins, right? But if you say the pins, it's okay. The 3rd and the 90th pins are where the power supply, the input from the motherboard, and then after passing through the MOSFET, the MOSFET of the power board outputs the 24 voltages. So input and after MOSFET and then output. So okay, and the 4 is MOSFET and the inductor. It's the inductor, and we can get the inductor. Get an inductor here. Which one is the inductor? I will show you. This one. This one is the inductor, and this is the MOSFET. These two MOSFET, but this one they don't have this MOSFET, and also this they need the three inductors, but this one just use 2 because they collect together. They collect together, and
in parallel,
because they are in parallel. These 3 is in parallel. These 3 inductors are they in parallel. They just for the output. They just for the high voltage.
in parallel,
In parallel here. Okay, and I will show you the others. Also the inductors, also for output. The output terminal pin 4. This 4 is created output after the MOSFET is turned on with a voltage of 24. It's the inductor. The inductor is the inductor. The pin 4. And the 10 and 24 is negative 5 negative. 10 and 24 is a negative with the transfer. It's a transfer. Which one is the transfer here? This is the transfer. This one, transfer. This transfer we get the voltage here, and we just translate the Chinese to English. Okay. Oh, sorry. The 10th and the 24th pins are the power board. After voltage transformation, transformer. Maybe we should use this transformer. Okay, this one is okay. Transformer. The 24 are the power board after the voltage transformation. Yes, transformation. Okay, transformation. Negative 24 is output. This one is for output. Usually this one is 12 to negative and 13. It's okay. It's also okay. And this is for the current. The current sense. If the current is high, this one will should get we can get the standby voltage, and also we can get the current sense. Because if the current is much high, here we get the current sense. Why we can get here? Because this is the MOSFET and this is the input. This one is the input, and after this is the MOSFET. If the current is high, because we say the MOSFET inside of the MOSFET also get a very small resistance. If the current is high, and we get a different voltage here, and after the MOSFET, the voltage will be no the input, so we can get the current. We can protect. We can show to the microchip the current is high. You should to turn off this power board. Here is the current sense. So every pin has this function. We should know every pin of this board, and after this I will give you a table. To show the function of these pins. So don't worry. I will give you a table for you to identify the pins of this power board. To Caterpillar standard, the power supply board does not have a high current. The short is directly ground through the transistor. Yes, and the 13 pins is the temperature, because the temperature here we get a temperature sensor. Here, and we can check the temperature of the power board. So this design is also very different. It's difficult, right? We get a sensor of temperature here, temperature sensor. We get a temperature sensor here. This one is a temperature sensor. So the 13 pins is the signal of the temperature sensor. Okay. 13 is the signal of the temperature sensor, and 17 and 18 is the positive 15 voltage. It's for the I/O. Most for the I/O, just like the monitor and the hydraulic ECM. So if you can study the Caterpillar, so most of them, especially the power the power part, they are the same one. I'm familiar with this because C7 is so simple for me. It's a small piece of cake. So I just try to teach you this. C7, C9, and C11 or C13, they are the same one. The hardware are same. And this board can, the most of them, if they use all of them, this one can just a driver for 24 injectors. 傻了吗？我们一直在直播，他还说没有检测到未进行任何活动，是不是个傻子？没声音吗？喂，这不是有吗？他还在这儿唧唧歪歪。TikTok 有时候也是个傻子，谁都是傻子。And 28 and 29 is the transfer from 24 to 7. It's a main 7. It's very important voltage. So if you want to repair the Caterpillar C7, C19, and C15, you should know the group. You should know the power board. If you know nothing about the power board, you cannot repair. You cannot repair the ECM because it has a lot of power in this board. It's a little bit difficult. These pins are just for fixed and they don't have electronic functions. Okay, here we get the functions of this. Okay, we just cut this to our world. 是不是我的摄像头开的太小了啊？摄像头开大一点，或者光头太亮啊，没分辨出来。Okay, this is the power board, and we use 3 pins here, and after this we get the power board, and also we get a very small battery here. Because the battery, why need the battery? Here we get a battery. Okay, this one purple, the battery, a small battery. This one is the full battery. This one. Usually this one is just 3.7 a battery, small battery, 3.7 the voltage. Why we have this one? Because some of the configurations we need this one configuration. If this one is this one is broken, the configuration will lost. This one is also very important. So the C7, this one is used for protect the ECM because the American and the Japanese they just designed the ECM and they want to protect the ECM. So they get a very small battery here and they want to use this battery to protect their design. If you remove the power board, some of the configurations were lost. Some of the configuration. Thank you. Hi. Great. Okay. Thank you. Some of the configuration were lost. Here, a small battery. Okay, small battery and used for the SRAM, the RAM. You know, we get a RAM in the motherboard. So this is just for the RAM. So some of the configuration is in the RAM. It's difficult, right? Here is the battery. 26 is the slot, the backup battery, which is used for the SRAM of the main unit. Lose this power. If we power down, this is a battery. 待会儿露出我性感的大屁股，一过去，早都已经给你泡上了一杯，整吧。For explain this ECM. Okay, you are welcome. I will get some water to drink and for my wife. Wait a moment. 装不装啊？一定要强调一下，在家里对老婆吆五喝六的，在外面都假装哦，I love my wife, right？ 是不是吧 ？Okay, I'm back. Okay, this one is just the capacitor for input. Okay, input. These two input, and so we will get these two for input. This one and also this one. Both of them have 2, but this one just 1. And the only one is also okay. This is the input filter capacitor. So if we have input and we also get the output, these two are output is for the high voltage for the injectors. The injectors need a very big current. So these two capacitor they collect together, and the voltage in series, in series,
in series,
in series. What are you doing? What are you doing? In series, in series, in series. Oh, here, these two capacitors, they are in series. We will check here, ground and this the positive here we get. Here is just used for fix and ground, and this one connect to this one and this to ground. After this, we output here. So these two are in series, in series, in series, right?
in series,
In series,
in series,
in series, in series. So I don't want to make mistake, so I should double check, transfer, and in series. The injectors here, the injectors here, we get the two capacitors. They just in series, and this is to use the power after we power off. And this resistance is the node to shut down the power, right? Here we get the two, and this one also can protect the capacitor and from because the charge current is too high. So if we use these resistors, we can let the current down and to protect the capacitors. C3 and C4, we can check here, right? These two will highlight. These two will highlight. So this is the capacitor for capacitors in series output in series. But this is in pairs in series. This is in series, and they are for the here in series. In series capacitors for high voltage, here high voltage, and these two in pairs, in series and in pairs, in series,
in parallel,
in parallel, in parallel, in parallel. They are in parallel, in series and in parallel. These two are in parallel. So we just need one. It's okay. Okay, this is the input MOSFET, and this is the diode. So if they don't want to the input MOSFET, these are input MOSFET. These two, and we can just cut them down and just use a diode. These two are diode input. So if these MOSFETs are broken, so you just can cut it down. Input MOSFET. If broken, just cut it down. If broken, just remove and short this file and short this diode and use this diode to short this. But you should very familiar with this board. So I am very familiar with this board. I can just change them and diode. And this one is for the transistor to the low power voltage transistor switch for the transistor. MOSFET, also MOSFET, transistor, transformer. This is for transformer. MOSFET is for transformer. Switch. The function is for switch. Also, this one is also for switch. Transformer. These three for boost. This is for boost. Why? MOSFET for boost. MOSFET is okay. MOSFET for boost. High voltage. Also, function is used for switch. Yes. And this inductor. Input inductor. Come on. Input inductor. This inductor is very important. It prevents the injectors, especially the injectors. If the injectors have a very high voltage, and this can protect and it's stable the voltage, and this also inductor for the boost. Okay, so it's very simple for this C7. As for me, it's a small piece of cake, and okay, here is the top side, and this is the bottom side of the power board, right? And here we get the three pins. How to power on? Here we go. And I will show you the detail of this power board. Here we get 1, 2, 3, 4, 5 sheets, 5 schematic files. This is the temp sensor, okay? And the caterpillar IC will check the temperature. The caterpillar, okay. C13. the caterpillar chip will check the temperature of the power board. And here is very important. Here, first we get a standby voltage. Standby voltage. The standby voltage is very important. Also 7, but we get another 7 voltage. Another 7 voltage is used for the main power, and this is just for standby. Standby. Why we need a standby voltage? The standby voltage is used for the RAM. The standby voltage used for the RAM. And after this diode, after this transfer, we get a standby voltage. Standby voltage 21, right? We get the 21, standby 7. So if the battery is okay, the battery of excavator, if collect the battery, we get a standby 7, and it's for RAM. We don't need the small battery. Which is the small battery? Here we get a small battery. It's a purple one. A small battery is also for RAM. So if the voltage comes from the battery of the excavators, so we don't need this one. Why? Why don't we need this one? Because we get a standby 7. And how we can check the standby 7 and the battery, how we can change them? It has a small switch, I say, to change them automatically, to change from the standby voltage or to the small battery of the board, the power board. And we can get a lot of the issue here. The inductor, this inductor can burn a hole here, this one, the inductor. Usually here, we get a hole, it's burn because the current is very high and the hole is too, the pad of this PCB is small. So usually we can get a hole here, and after we get a hole, we can just dig the hole and then collect the wire from here to here, and this pin to here. If one is input and one is output, so it's simple for us to repair. With a hole, you don't be afraid of it. Just ask me to help you. And this one we can often get a very big hole here. Why? Because not current, so it's usually get a very big hole here. So we just move them here and also up. Okay, let's put the note here. It's useful for you, right? L5 is a I-shape inductor, or the not current for boosting and equalization and filled by this, and they provide due to the net current following through. It generates get a lot of heat because the current can make the heat, Therefore, the contact point of this inductor is often to burn out and get a hole here. And these two, one is the input before the inductor and another one is after the inductor. Here we get the two capacitor here. One is before the inductor and another one is after the inductor. Okay, get it? Okay, this page is finished. Another page, maybe next time. It's too late. Now it's another day, so maybe we need to have a rest. And thanks for watching this night. Okay, bye bye and good night.